Welcome to this session. This session, we are going to start introducing different types of matrices. So let's start by first type of matrix called the row matrix, or sometimes it's called row vector. So this is a matrix with only one row and any number of columns. Sometimes it's also called row vector. So that's the definition of a row matrix. So examples, we can have 1, and then we can have 1, 2, 4. We can have 1, 8, 9, 10. So you can actually separate elements just by spaces, not necessarily putting commas. We can have 1, 3, 9, -7, 8, etc. So these are examples of row matrices. So if you are to determine the order of this matrix, this is a matrix of order 1 by 1. This is a matrix of order 1 by, so first column, second, third, 3. This is 1 by 1, 2, 3, 4. Order of this one is 1 by 1, 2, 3, 4, 5. So that's what we call a row matrix. Column matrix. So this is a matrix with only one column and any number of rows. It is also called a column vector. So examples, the same example we gave one is still can be classified as column matrix. 2, 4 is another example. A minus 3, 7 is another example. 4, 5, 3 minus 1 is another example, etc. So if you are to specify the order, then you say this is 1 by 1. This one is 2 by 1. This one is 3 by 1. This one is 4 by 1. So those are examples of column matrices, or sometimes simply called column vectors. Number 3 is what we call null or zero matrix. Now, null or zero matrix is any matrix in which all the elements are zero, or you can say are zeros. E.g., if you say 0, 0, 0, 0, you say 0, 0, 0, 0, 0, 0. If you say 0, 0, 0, 0, 0, 0, 0, 0, 0, or you can say 0, 0, 0, 0, 0, or 0, 0, 0, 0, 0, 0, etc. All these are null or zero matrices because all the elements of these matrices are zeros. Now, fourth definition is what we call square matrix. A square matrix is any matrix whose number of rows equal the number of columns. So we say a matrix in which the number of rows and columns are equal is called a square matrix. E.g., even this one is a square matrix because we have all of this one is 1 by 1. So number of rows and number of columns are equal. Another example, 2, 9, minus 7, 9. This is also another example. If we have 3, 4, 0, 1, 2, minus 1, negative 1, 3, minus 4, or if I have 2, 1, 4, 1, 0, 1, 2, 1, 2, 4, 3, 4, 1, 2, 0, 0, all these are square matrices because the number of rows in each of these examples equal the number of columns. Like this is 2 by 2, this is 3 by 3, this one is 4 by 4. And then number 5 is what we call diagonal matrix. Now, a diagonal matrix, a square matrix, the first thing is that for you to define diagonal, then it must be square. That's the starting point. So this is a square matrix. Whose of diagonal, whose of principal diagonal entries or elements are 0. E.g., if you have a matrix of the form 1, 0, 0, 0, 3, 0, 0, 0, 4. This is an example of a diagonal matrix. So the thing is that all elements that are not on the principal diagonal, remember principal diagonal is this diagonal running from top left to bottom right. This is what we call the principal diagonal. So if we have a square matrix which has elements in such a way that all elements outside this main diagonal are all zeros, then that's a diagonal matrix. Another example, we can say 4, 0, 0, 9. Another example, we can say 3, 0, 0, 0, 0, 0, 0, 0, 9. Remember, the condition is that all the off diagonal entries must be 0, and at least one of the element along the main diagonal is not 0. Actually, you can say the square matrix whose of principal diagonal elements are zeros, and at least one element on the main diagonal or principal diagonal. Principal and main mean the same thing. Principal diagonal is non-zero. So despite the fact that this element is 0, but all of principal diagonal elements are zeros, and we have at least 9 0 element here. So this also a diagonal. That's a diagonal matrix. And you can give several examples of the same type. And then lastly, that's number 6, what you call scalar matrix. Now, you define a scalar matrix from diagonal matrix. So you say this is a diagonal matrix in which all the principal diagonal elements are equal to a scalar, say k, are equal to a scalar, say k. E.g., if we have a matrix of this form 2, 0, 0, 0, 2, 0, 0, 0, 2. This is a scalar matrix because already it's diagonal and it can be written as twice 1 0 0 0 1 0 0 0 1. So this is an example of a scalar matrix. Another example, if you have a matrix of the form -6 0 0 0 0 -6 0 0 0 0 -6 0 0 0 0 -6 is also a scalar matrix because the first thing is square and the second thing is diagonal, and you can write it as factoring out -6 1 0 0 0 0 0 0 1 0 0 0 0 1. Or you can say another matrix of the form 24 0 0 12 is scalar because we can write this one as 12 and then 2 0 0 1. So, and you can have as many examples as you can. So the next session will give more examples on different types of matrices. So please don't hesitate to check them out. Thank you.